webinar. This is an interesting topic, this one. Some people may know, I guess it's in the area of vehicle tracking, but what we'll do is we'll talk a little bit about the history of the program and some live demonstrations. So let's get on our way. All right, so the product today is Autodesk Vehicle Tracking, being presented by Morgan Smith. I'm the technical consultant for A2K Technologies in the area of civil and geospatial. Excuse me, you have to just excuse my voice. I've got a bit of a sore throat today. So the agenda today, what I'll do is I'll just quickly give a quick intro about what A2K Technologies is and what we do, and then from there we'll talk about an overview of the program, a little bit of history, where it actually came from, what's relevant now, and then from there I'll just cherry pick a couple of key features that the program is known for and a couple that you may not know, and then what I'll do from there is I'll actually go through 3 or 4 worked examples of how to actually use the product, and then from there we can talk a little bit about some questions and answers, and also some bits and pieces about some up and coming webinars. So a little bit about A2K Technologies. We've only been, A2K has only existed for probably about, since about February, when there was a merger. So you may be familiar with names like, if you're in Australia, and ADA CAD Partners, AEC Systems, and CAD, they actually merged together to form A2K Technologies. So if you're not sure, or you've heard the name A2K and you weren't sure where the other guys went, that's what happened at a merger. So as a result of that, we have more staff, so we can actually provide more services for you, depending on what you want to do. So we don't just an Autodesk reseller, but we also do provide a lot of other goods and services to our clients in relation to hardware and software. For example, you can see on the screen capture here, obviously we've got Autodesk there, but we also do Adobe, and also, so for example, hardware, we've got HP there, and other things like tablets and mice and other software products. This pie chart probably gives us a really good overview of sort of where or what A2K does. So for example, me being a technical consultant, I actually work in the following, in these areas here, so in technical knowledge, I also do a lot of training and consulting, and also in the support area as well. So quite often if you have a technical query and you need to call us up or correspond to us via email, you'll probably find that you'll be talking to me, especially in the areas of Civil 3D and AutoCAD. So with the company becoming bigger, what we've actually been able to do is we've been able to pool our resources now, and as a result of that, we can actually deliver more innovation services to you as a customer, and also we found that it doesn't matter who you are, whether you're just a one-man band, as they say, or a small, medium enterprise, or to even the large enterprise customers, because our background is from all those different areas, then we have an understanding of where you are, so we can help you out with things. So here's a pretty picture of myself. So now everybody can recognise me on the street. I'm now famous. So so my role at A2K is I'm a technical consultant, and my background is basically civil engineering, and I've been doing that for about 20 years now. So I started out sort of in the areas of site development, doing road widenings and car parks, then moving on to more site development projects, so hospitals, did a little bit of stadium work, and also some area in the hospitals. And then from there I then moved on to what they call significantly larger infrastructure projects, so the massive roads and highways and tunnelling projects. Because I'm based in Brisbane, in Australia, I've also had an opportunity to work on the Airport Link project. They recently finished in Brisbane, so very interesting. Probably one of the other ones is what they call the Road Natural Disaster Road Relief Program. When back a couple of years ago, when the east coast of Australia had a lot of cyclones and floods, I was part of the team that actually helped produce a lot of documentation to rebuild the roads and things like that. So as I've gone along in my 20 years experience, I've also been a CAD manager for quite a few of those. So spent a lot of time managing CAD programs, platforms, and also working closely with IT departments, so on installation, deployment, and licensing of Autodesk products. So when you contact us, or if you've got queries, I can pretty much answer most of your questions. If not, I've got a little hotline to Autodesk, and they can actually answer some of the questions if I don't know them, so it's all good. As you can see, I'm a qualified senior civil draftsperson, and I'm also a member of IOS Australia as well. Okay, this is the reason why we're here. It's Autodesk Vehicle Tracking. So what we'll do is go through a bit of a quick overview and sort of, what the product is and etc. Okay, so quick history lesson. Up till recently, it was previously known as AutoTrack, and what it actually had in it was a whole heap of different modules. So, for example, the little screen captures I've got there. So there was roads, airports, rail, parking, and junctions, or what you want to call roundabouts. That's a UK term. And at the time, they were known as the industry leader in the field of vehicle swept path prediction and analysis. So from that point, so that's sort of, sort of a bit of history. Now we're going to the present day. So you probably saw the information in the newsletters and the blogs posting that AutoTrack had been acquired by Autodesk. Originally, it was written and sold by a company that was called Savoy Computing Services, and they were based in the UK. And as a result of Autodesk acquiring AutoTrack, now you don't have to actually buy the individual modules that were available with AutoTrack. When you buy vehicle tracking, you actually get a single product, and all modules are included in the product. And as we've gone along, made some more improvements. So it still is the comprehensive transportation analysis and design solution for vehicle swept path analysis. So a little bit about vehicle tracking for those that probably have never used it before. It's basically a comprehensive transportation analysis and design solution for swept vehicle analysis. So what it does is it's almost like an essential addition to your current civil infrastructure software portfolio. And what that does is that provides benefits to your civil engineering team that are working on especially transportation and site design projects. So probably some of the key benefits of the product is that you can accurately predict the movement of steered vehicles, including cars, trucks, vehicles, and airplanes. With that, you can also then go through and then optimize the road geometry and car parking layouts. So what that allows you to do is so you can, with the automated tools, that allows you to optimize and quickly evaluate design alternatives. And then finally, what we would call your relevant performance or real-time analysis. So quickly get the information that you need and the necessary feedback to make the next design decision as you go along. And then what you can also do is, because it has design standards built into the program, you can also monitor what you would call adherence to those standards. Okay, so with the purchase of vehicle tracking, they're now integrated into the Autodesk software. I do believe that there was previous support for other platforms when it was owned previously by Savoy. as far as I know now, because it's an Autodesk product that only Autodesk products are supplied on that. So, you know, they're integrated with some, but not all products. So, for example, it's integrated with AutoCAD, Plant 3D, AutoCAD Civil 3D, Map 3D, AutoCAD Architecture, and AutoCAD Utility Design. Now notice I haven't listed all of the AutoCAD verticals there, but pretty much anything that's an AutoCAD vertical, vehicle tracking will work inside of. And if it doesn't, then you know, just give us a call, and we'll try and figure out a solution there to help you out. So lots of different disciplines and programs that you can actually then work with. Okay, some of the key features. So probably the number feature is accurately predict movements of steered vehicles. So most infrastructure projects require some sort of analysis to determine if proposed road geometry can support the movement of your vehicle. So with vehicle tracking, you can then select the appropriate vehicle and then determine that very quickly. So with the library, there is an extensive library. My screenshot here is a little bit small, but as I go through the demo, I'll flick through the vehicle library so you can sort of see how much there is there. Because it's a program that's used across the globe, it's roughly around about in excess of about 500 vehicles that can be used within the program. So moving on a little bit further. So my first point here, the vehicle diagram that shows specific information. So when you select a vehicle, you can also place a graphic in the program so you can actually see what the dimensions of the vehicle is at any time. So clearances, wheelbase, width, height, those sort of things. Okay, so once you actually start drawing your vehicle track in the horizontal space, you can actually see exactly where the vehicle goes, the extent of the vehicle, how far, what do you call it, the wall-to-wall or the curb-to-curb settings, so you know exactly what your envelope is. Then from there, you can then actually refine that using groups. So once the object's placed, it's a matter of selecting the object, and then you can just move it around to manipulate it to suit what you want to do. And then as you change those groups, then the results are displayed dynamically on the screen. Also, the advantage of this is that as you make your modifications, it will become very obvious straight away when a design solution is not available, because the vehicle path itself will actually break and be incomplete. So you'll know straight away whether it's broken or not. Okay, the next part. So animating your analysis. So I've got a little video here as I sort of talk. So what I found is in the past I've used the program quite a lot myself, that the 2D representation is hard to visualize, and so our little animation here isn't too sophisticated. It doesn't really have a surface. All it's really doing is it's just driving along on a UCS of 0, and it's just basically a flat plane so we can see what it is. So you can experience the vehicle movements in 3D. So as you go through and you watch the video, so the example here now is it's actually performing a reversing maneuver, so you can actually switch between different camera angles on the vehicle to actually see what the driver can see, and you have different mirror vantage points. So there you go, analyze and present different vantage points, so that way as you're evaluating the design, you can actually see what's going on around. The next item here, I touched on this earlier, which is optimizing what we call road geometry and parking layouts. This is a great feature because what it actually does is it actually uses dynamic objects. So as you're using the features, because the geometric standard is built into this, so if you're in Australia, use the Australian standard. Basically what you can do is you can set it up in respect to the driving bay width, the aisles, handicap spaces, and as you go, because it's all dynamic, you can actually just grab the grips and manipulate it as you go to shape your car park and your aisles. Then we move on to junctions or roundabouts, exactly in the same way. You can see in this little picture there, all the little blue grips on the roundabout. Each aspect of that, so the lane width or the tapers, the islands, all those sort of things, they're all dynamic as well. So just like on the vehicle path, as the change is made, the results are dynamically displayed on the screen. So that way you have immediate feedback on your design. And most importantly, the last bit here is the ability to define your own standards. So there are some standards provided in the product. So depending on your region, you can actually, if it doesn't exist, you can actually start with an existing standard and then actually modify that to suit. Okay, so moving on to junctions or roundabouts. So when I first used this tool, I was actually quite blown away about how powerful it is and the dynamic of it. So later on, when I do the demonstration, we'll basically walk through how to do a preliminary layout, and then from there, we can show you how to do the, what do you call it, the rapid editing ability of the roundabout. So that way, it's all constrained, geometrically constrained for the other objects. So once you make one change, then another part of the roundabout will actually change. So if you're changing lane width on a particular leg, then it will also adjust the island shape as well. And when I used to design roundabout, it was actually quite a tedious process. You have to draw your arcs, and then you have to do your TTRs, and then set your radiuses, everything like that. But as we go through this, what it basically allows you to do is, as you're making your edits, you can go through, alter each leg, whether it be approach or the lane, and that way you can quickly explore what the different option is, what the widths are, how does that impact on your road corridor, and also use, highlighted earlier, established design standards, so that's some of them as well, and also reduce the time spent. Okay, so my background is Civil 3D, so today's demonstrations will be in Civil 3D, and so some of the great things about AutoTrack is it has unique integration with Civil 3D. Cool thing about it is it will interact with your surfaces, and it also corridor objects as well. So probably the best way to highlight this is that Civil 3D will actually, Vehicle Tracking will interact with Civil 3D roadway surface objects to perform ground conflict checks, so you can see where and to what extent the vehicle will impact the crown on the roadway. So in the graphic here, you can see there's an area of green and yellow where the trailer's sitting, and then you can actually know how much the clash is or how much clearance you actually have before the trailer will actually drag on the existing surface. You can also, excuse me, you can also drive on 3D surfaces. You can create, create Civil 3D objects as required and automatically construct a Civil 3D corridor. I've got my notes around the wrong way here, but that one there refers to actual roundabouts. So once we actually draw our junction and we model it up, we can then tick a couple of boxes, and Vehicle Tracking will actually go through and actually start creating your corridor and modeling it all up for you. And then the final point here is it drives on 3D surfaces. So just like my video before, even though I technically didn't have a surface because my model is at RL0, and I could just draw my 3D vehicle straight over the top of that. So that was pretty cool. Okay, so with the real-time analysis on the roundabouts, on the graphic here, there's a little box, and what that basically shows is as you make adjustments to your roundabout, it will actually give you feedback on so let's call your fast lane speed or your straight through drive speed, and so that way you can automatically determine how fast the vehicles are actually moving through each leg of the roundabout. So, example, fastest path and performance data. So, a little bit small, but as I go through the demonstration, I'll go through that a little bit more. Okay. One of the great things is, especially when it comes to safety, you can also do sight lines based on standard design speed. So that way, once you're actually drawing your vehicle path, it will automatically show the ray traces, so you can see what your sight distance is and how and what the actual driver can actually see as they're going along. One of the other cool things is that because it's a vehicle and you specify your steering angles and also your articulation angles for your semi-trailers and things like that, there's actually a steering diagram that will actually tell you when you're actually starting to exceed those specified limits, and then you can go back through and then actually determine, okay, where that is, and then make the necessary adjustments. Now, it also does calculate what one calls speed-dependent transitions at entry and exit points. So it will do that for all turns, both forward and reverse, unless it's unless it's overridden by yourself. So as you can see, vehicle tracking has quite a few features that helps you evaluate the safety and standards compliance. So in regards to your parking lot layout, emergency vehicle access, loading bays, and that sort of thing. I haven't touched on this yet, but you can also, with these tools, you can also analyze vertical clearance, your vertical grades, 2D or cross-bore geometry using the 3D vehicles. So most commonly, in the past, most of them have all been two-dimensional, but now with being able to leverage the civil 3D objects in the model, we can actually do a lot more, especially in the 3D. So, quick wrap up before we do the demo. So, vehicle tracking is basically a comprehensive transport analysis and design solution for vehicle swept path. So, what we're going to look at today is sort of to do with vehicles and cars. I've steered vehicles, but in my field, I mostly did roads and where I was using trucks and stuff like that. But I've had colleagues who have been modelling aircraft, so they found it very handy for doing aircraft and also vehicles on airside. So if you're doing your luggage trolleys and all those sort of bits and pieces, they're in there as well. And there's also the ability to support light rail as well. So, and just recapping on what I had before. So, all right, let's get into the demo. Always like some live demos, so show you a bit more about the product. So, what I'm going to do is just do a quick. So there's going to be 4 examples that I'm going to do today. One is just a quick turning manoeuvre, and then through a roundabout, a quick design of a what do you want to call it, a truck reversing into a vehicle bay. Also doing a car park layout, a quick vertical analysis of a low loader turning through an intersection, and then the final one will be just a quick model of a junction. So, okay. All right. So here we are in Civil 3D. First time when you start vehicle tracking, it doesn't actually have any icons in the desktop, but if you go to down into here, Autodesk, sorry, wrong one. Nope, it didn't even have it in the start menu. When I first installed the product, it actually had a shortcut in the start menu. Once it's actually installed, it's automatically integrated with Civil 3D, and it actually has AutoCAD Vertical, and a menu like this will actually show up and have the words vehicle tracking, and all the tools are shown on the ribbon. Now, important one that is, if you decide to download a trial from the Autodesk website, there are certain restrictions I found with the licensing when installing it. It sort of has to be or like for like. So if you've got a standalone version, you should be able to install a trial version fairly easily. If you have a network version and tried to run a trial version of AutoTrack, I found that it says unable to find a license. So if you have installed a product on your machine, you want to perform a trial, and you do having some issues with that, feel free to give us a call or contact us in the support, and we can go through the licensing options just to make sure we can get it up and running for you. Okay, so here's our road. So what we're going to do is we're going to drive on the left-hand side of the road, come into our right turn slip, and then through the intersection, and then up, and then do a left-hand turn at the roundabout. So to get started, we go to our vehicle library. Okay. When you fire up vehicle tracking, I've actually got a license for it at the moment, so only when you actually start using the tools that you will actually gain a license from the Network License Manager, or if you've got a standalone, it just activates the license. So mine's a borrowed. So it fires up the vehicle library, and as I said earlier, there's about 500 different vehicles. So for our clients that are in Australia and New Zealand, there is an Australian library here with all the off-roads, and a bit further down in New Zealand, we also have another library there as well with all the different. Just add a little bit more, so you can see all your different standard vehicles in there. Like that. So Australian standard gives you all your percentiles, and all your different types of vehicles there. So all the examples I'm going to do today will actually be Australian vehicles, because that's what I'm sort of familiar with the most. And yep, so I'll explain what the vehicles are as I go through. So today I'm going to use the off-road standard for 2013, and the design vehicle I'm going to use is just your standard service vehicle. A note here, when you click on the vehicle, it also has other details there. On this side here, we also have other icons down the bottom here. So at the moment, we've just got our graphic. If we want to just see the basic frame or the outlines, we can actually go through and just switch those on and off. Go to the next graphic, and we can also see the vehicle dimensions in a vertical dimension. All right, so I'm happy with that vehicle, so I'll just highlight it, go OK. Try that again. Okay. If I double click on it, it will ask if you want your default vehicle. So if you are using it quite often, you can actually set that to default. I'll just set that to no. Then I'll receive a prompt about the scale of my drawing. I've already set the units in this drawing here, so it's 1 unit is 1 meter, and then there are other value information in here, especially about surfaces. So if you're in Civil 3D, you can actually give it instructions on what surfaces to interact with, and then from there on, paths relate to your layers and things like that. All right, so we go OK, and once we've selected our vehicle, click on the screen, and then specify the direction. And then from here, there's similar information as we had before. We're just going to get straight into it, so proceed. And as I move the vehicle, what I'm doing is just doing a left mouse button click, and I trace my vehicle. So as I come up to my intersection, as I go through the corner, I just keep on tracing. Okay. Now I come up to my roundabout. Like that. Okay. So there's our path. through the roundabout. Now notice as I've drawn the vehicle, there's different coloured outlines there. So what happens there is the red lines there are actually the outlines of your wheels, and then the actual green one is the actual outline of the vehicle itself. So if I go back to my original position here, you can see as I've driven along, come along, and there's all the grips there that we can edit. So if I find, going back to my roundabout here, I want to make a modification, I don't want to swing out into the traffic, I grab my grip, and notice as I move it inwards, all of a sudden it gets to a point where I can't find a solution. That means the vehicle can't physically steer. So what we need to do is we just need to make some modifications and just pull that in a little bit, like that, so that way the vehicle's not swinging through like that. All right, so if you wanted to quickly have a look to see what the vehicle movements and things like that, you can actually just click on Animate and grab the slider. Now what I haven't been able to do is actually pan and zoom as you go, but as you can see here, you can just grab the slider, go back and forth, and actually watch the vehicle turn as it goes through the movement. So really simple. Now that we've placed our vehicle path, what we really need, we need to now check our vehicle steering angle just to make sure it's not exceeding the specification. So come back over to this area here, and there's this one here called Insert Graph. And so what this will do is display articulation angles for the vehicle. I'll just place this over here. All right, so when we look closely at the vehicle path, so this is the allowable limit here in the middle. And as we've made our vehicle turning maneuvers, it's feeding back to all the steering angles. There's at one point there, it's actually gotten pretty close. And up there, it also has the same as well. Now, what you can do, trying to remember, you can actually generate a report as well. So it will actually tell you what the issues are there. That's this guy here. So click on the vehicle check, and because these are within the allowable limits, there actually are no exceptions. If at any point, let's close that. So if at any point this actually came down and actually touched that, it would actually flag and say that you need to go back and actually fix that up. So this one here is my right turn down the bottom, and then the other one here is the maneuver as I've gone into the roundabout. And you can see there that I'm a bit of a wonky driver, a lot of steering input there on the steering wheel as I've driven. So that's a real basic layout. What we'll do now is we'll now go into, we'll do another example of an intersection. So basically, I drive the vehicle, come down through, and then perform a reversing maneuver, and then go into the loading bay here. So just like before, come across to our auto drive arc tool, come in, select our vehicle. Now, every time we select a vehicle in a drawing, I've previously selected this vehicle, so I'm using it again. If it's not the correct vehicle, you can just go back up to your appropriate library and then select it again, go proceed. Again, it asks you the default vehicle. If you don't want to see that, you can just tick that box and say don't see again. Okay, same questions again. So we'll just go OK through that. And we now place our vehicle there. Okay, click proceed. And again, we trace our vehicle up. Now, I'll get to this point here because there's some neat little tricks here with the auto drive. Over here, we have what they call a pick alignment. So I could just sit there and I could just trace off the vehicle whichever direction I want. But if I want to run parallel to particular objects, I can pick alignment and pick the object. And then as I move my cursor, the vehicle will remain parallel to the objects there. So we'll just click that. out there. All right. Now we're going to turn to the right, so we'll do the same again. Pick alignment. And now we're going to do a reversing maneuver back down into here, so we pick alignment again. And click on that. Okay, there's our vehicle movements, and you can see this time in the previous example we just had the crosses and the pluses. This time, because we've actually used the pick alignment options, we actually have blue groups, and if we can, then what we can do is we can adjust the amount of oversteer as we're performing our maneuvers. So it gives us a little bit of leeway there. So we can then fudge that and make refinements to our design as we go. So just move that up a little bit further there, and also it makes some adjustments like that. All right, so as I've gone through, you can see now the vehicle's driven on the wrong side of the road there in order to make the maneuver, and then come up parallel to the car parks, and then it's doing the reverse maneuvering into the bay. Now, what I'd really like to do is actually check to make sure, do a quick animation just to see what it looks like. So I can, just like before, I come back to the Animate button, but this time this one's actually a 3D model. So I click Animate in 3D. Okay. So what I'll do is I'll just move this forward a bit and just make some adjustments. Okay, so now we press play, and then we can actually see the vehicle maneuvering as it goes around the corner. I've just got some basic trees and some buildings in here. Put that up there. And as you go along, there are different paths that you want to choose. For example, the driver's eye. So as they're going along and then maneuvering, they can actually, you can see what the visibility is like as you're turning the corner, and then also you can enable what they call a mirror view. So as the driver is actually starting to reverse the vehicle, it will actually start altering that. Almost there. Okay. So now we're in reverse, and as we're going up, we can actually see different paths there. We can switch back and forth between the two. So as it keeps on going, the vehicle will reverse up and then make the maneuver. Now, while it's doing that, there are other settings there, so you can actually, once you've done your design, you can then actually create an API of that and then send that to your client. And then they can actually review the design and say, yep, that's awesome, love your work. And then you can just sort of, and then you say, oh no, that's terrible. We can't see that. We need to make some more changes. And you go, okay, that's fine. And then you go through and then you can make those changes. So I'll just speed up the reversing a little bit more, and then it will just come to a stop. Once I've finished, I then close, and that's my design finished. So the next example that I'm going to do now is actually a car park using the parking tools. This is a great tool when I first started using it. Today's example, we're going to use the Australian standard. They also New Zealand standard there as well for the Australian standards and the different options. Again, I'm familiar with the Australian standard, so I'm going to use that today. So I guess it doesn't really matter which class I use. I'm going to use what they call the short-term and the high turnover parking in a shopping centre. Basically, it's going to be for vehicles turning into this area here. So select my standard, I go OK, and then I get a big panel here and basically that allows me to control my options as I'm drawing a modification. So before you start doing it, before you start modeling, you can actually change different things like your bay angles, where are we, and your bay style, so whether they're disabled or shared areas and things like that. That is for left only or both or right only. So now that I've run the tool, you can see that my cursor has changed. So I'll just turn my snaps on. I click my first point, and as I start drawing, it automatically starts, the graphic reflects what's actually been entered into the panel. So as I go through, zoom in a bit more, I draw my car park, clicking all the way around. Once I've finished drawing the perimeter, I then click enter, and the graphics then updates with the big arrows. Basically, they're saying, do you want it on the inside or the outside? I'd like it on the inside, and the graphic will change, and then it will then complete and update it. You can see once it's drawn, it's actually one object, and it's automatically spaced and filled in all your corners, and it's even giving you an indicative aisle width there. Now, obviously these parks here, we would like to push those out to the perimeter, so we grab our grip and nearest, select the edge, then I'll come in, do the same again, nearest. And as we've done that, you can see it's now eliminated that island in the middle there, and it's still got all the appropriate spacing. So pretty cool, you know. When you're having to do this, you know, you've got to set up lines and then offset them and then make sure they're the right setting, and then especially these areas here, you know, they're quite complicated to set up, just trying to make sure you get the right spacing. So now that we've done the perimeter, we come to the next option. So how are we actually going to fill out the center of this? So normally we would put in some parallel rows. So let's go back to the tool, do a parallel row, and this time we click on the blue guidelines, and you'll notice that it will present a solution with what it thinks is best of filling that in. Now, obviously, that's not going to work, so we really need to actually draw in some rows manually. But just thought I'd show you that. Just that way you can automatically populate it very quickly. So go back to our new row, and again, got the graphics. I need to turn my snaps off, and I just click and click that. So that's the first one. For the next one. Now, at the moment, I'm just drawing these approximately in. I'm just using the guidelines to approximately place them. I've got a little bit of space left over there from the space. Okay. All right. So there are my islands. Now notice I've got a bit of a curved area here. So this is where our grips come in. If I want to dynamically shape the end of the island, there's two ways I can do it. I can grab one of the grips and automatically shape it like that, set the angle. Okay, it's still not quite right. So I then grab the individual one, and then I can pull that back like that. And as I do that, I'll set that a little bit more. It automatically then updates and alters them to suit. This one here, need a bit of a change there. Grab that one and grab that one. And this one's a nice straight one, so I can grab that one. Now notice I'm grabbing a different grip every time I do that. Okay, so there's my preliminary layout. It's all pretty tidy, but I really need to know how many car parks I've got. So back up to the ribbon, and we have here what they call a parking report. So come back in, and it tells us at the moment we've got just what they call a standard vehicle, and we've got 137, so I'll just write that down. All right, so you can also customize and also export that report, so that way you can record it as you go. Now, if we want to make some changes, so for example, we need some disabled car parks down near these buildings here, we can come back up to the toolbar and we have numerous different options here about how we want to modify it. So we want to put in some disabled car parks down here, so we really need to enter those. Make sure I select the right tool. Okay. Once the tool is active, it then says, okay, which of the bays do you want to modify? So I click the bottom one here and disabled. Okay. Then I click on this one here and then I can say it's a shared. And disabled. Okay, like that. And you can see as I've gone through, as it's put in the shared area, it's also made the adjustments, so it knows that as I'm making adjustments, it's dynamically changing and it's also updating to suit as well. We can also make some modifications to our rows. So with the options here, we can specify which way we want to do it. So if I want to skew the angle of the parking in one of these rows here, so I'll just cancel that. That's long object selected. Okay, that's better. All right, so we can also change the title of vehicle, but here the different bays. But what I'm interested in this time is to look at the bay angle. So I can then specify 45-degree contraflow like that, or I forgot to modify this other side. So here we've got both, we've got left only. So what I don't do is I need to change this one here to that as well. Edit another, go through. Okay. Go OK. Now we've made our modifications, but we really need to see how that impacts on the number of car parks we've got. So come back up to our report again, and our previous count was 137 with the standard vehicles, and we've also incorporated the disabled. Now notice, because we've put the angular contraflow parking bays in there now, we've actually reduced the amount of parking spaces that we have in there. Pretty cool. Really quick, you can model up different options and alternatives very quickly just by using all the different grips and the tools up here in the ribbon. Going for time, going good. Okay, I'd like to speed up a little bit. This next demonstration, unfortunately, I wasn't able to model an Australian metric one for this example. I ran out of time in preparation. So what I've ended up doing is grabbing a US imperial one. So you'll notice that it's on the right-hand side of the road, turning through the intersection, and then proceeding up the page. Now, this vehicle that we've got here, so we need to have a look at what it is. So I come up here to the profile tool, click on the path, and here's an example of what the graphic looks like. It gives me all the dimensions. So because this is a US imperial version, it's all annotated in feet. So if you look at the minimum ground clearance there, 0.4 of a foot, so that's just under, about 15 centimetres or 150 mils, I think, roughly, clearance under the lowest spot here. So what we're going to do is, as the vehicle will make the manoeuvre, we need to check to make sure if there's any vertical clearance issues as the vehicle turns. Now, at the moment, we've got our vehicle outlined there. We can see very easily what it is, but what we'd like to do is actually be able to see the vehicle as it turns through the intersection as well. So come back up and we can place an outline. So ask for our path, and we can then click on the screen and place some outlines like that. Now if I zoom in, we can now see the maneuver. So it's got a dual pivot point here. As the trailer moves through the intersection, we can see where it goes. Now, the important part is actually at this point here. Here's the crown of our road. The wheels are on this side of the right-hand side of the crown, and these are on the left-hand side of the crown. So we're obviously going to get a clash there. So what we need to do is we need to find out by how much that's actually clashing. So to do that, we come up to here, this tool here, and what that's basically doing is the vehicle itself is actually interacting with the civil 3D surface that I have in this drawing. So I do my ground conflict report. It says what path. Okay, go used to that. Okay, then it goes through, does all the calculations, selection there. Okay, so you can see as the vehicle moves through the intersection, we've got some green and some yellow. So basically what, if there's nothing shown, so for example, on the outside there, basically means that there's about 100 mil or more clearance. Once you get to the green areas, they're saying it's roughly about 50, 100 mils. Just pulling this straight in my head, I think that's what the values are in the help file. I'll have to double check those later, but I think from memory that's what they are. And then there's a yellow area here, so this here will be our concern. So that area there is between 0 and 50 mils. If we did have other colours, say for example orange, magenta and red, that will actually tell us that it's actually pushing through the pavement, and we have to review our design. Now, the great thing about doing the vertical clearance is if I make a modification to my vehicle path, it automatically disappears because as soon as the path is altered, the vertical clearance will change. So with that modification, I need to go back up and run it again and recalculate it. So you can see with that change, it's actually reduced the clearance a bit more and it's actually pushed that up a little bit further there. So not only can you check for other clearances under body, but because the program also knows the vertical height clearance, you can also do clashes in that way as well. So not only for just driveways, but the vehicle movements when you need to get within stay here, and certain trucks that need to go under bridges. I've seen examples of it actually being used with point clouds as well, which is very interesting. Okay, so that's the vertical clearance. Quick one, the last one. I may have to rush through this one. Is the what I call the roundabout or the junctions. So the example I've got is 2 alignments, Civil 3D, that I've pre-drawn. I have an existing surface here, and now I'm going to model up a roundabout. So first thing, I come up to my library, and has all my different standards. For today's demonstration, I'm going to use the British one here because there wasn't an Australian version in there, so it will look a little bit different as we go. So I'm just going to choose a single carriageway roundabout. Options again, they do have the ability to interact with surfaces, so we're going to specify that as we go. And also with our corridors, I'll currently untick that. So that way what we can do is we can actually just quickly go through our geometric layout, refine it, and once we finish, we'll build our corridor. So go OK. Opportunity to give it the name, so roundabout way. Also here gives you an option, depending on your backgrounds and things like that, it will change the style. So I'm using a dark background. Existing surface, go OK. It then asks us where we want to place the roundabout. I'm just going to choose close to the center. And once I've placed it, it then will ask me, okay, where do I want to, which arms am I using? I'll specify my first leg, and it starts drawing that in. Then my second leg. As I go, just keep on going around. Like that. And then go enter. Okay. Now my roundabout's all set up. It's all, you can see it's all linked to each other. I'll just change my scale here. Okay. All right. So as we place the objects, as I mentioned earlier, as I'm changing different information, so all my art radius values, and also my speeds as well, like that. It's also got signage, so you can place signage into the standard. So as you make the changes, it will also dynamically update as well. Right. At any time, if I want to make a change and I need to move the center of the roundabout, all the information and geometry all dynamically update, and it all remains to standard. All the signage, stop lines, the radiuses, and also the fast lane lines, they all update as well. Now, if I want to make some fine-tune, if I want to fine-tune my roundabout, I come back up, click the Edit Roundabout tool, select the roundabout, make that over there. I'll just look at this first leg. When we go to modify the roundabout, they do have other options in there. So if you have selected or changed something earlier on, you can then come back in and make another modification. So for example, if I've got to specify my existing surface, the first leg. All right, so we can go through and actually start modifying these. Now, when I click on the fields, it actually goes through the graphic or the diagram on the left-hand side will actually start changing as you actually select the field. So I want to change my approach width from 3.5 to 4.0. I can apply that change. It then goes through and dynamically updates that. And because it's all built into the standard, automatically adjusts all as you go. And then it's just a matter of going through, make some changes. Now, at the moment, I don't have a splitter island, so we can add that in. Go apply so we can see that on the screen. And it automatically will place that in there. There's our splitter island. And then from there, we can actually go through and actually specify all our offsets, everything like that. So that's all built into the standard. So what you'll find is most of the time, you'll be able to model up something really quickly, actually go through and have a look, see what's going on. We'd like to perform a swept analysis on this. So you can actually say what design vehicle you want. So let's choose a new one. Go back to my Australian vehicle. So this time I'm choosing 19-metre semi. Go OK. Well, so apply that. Close. Okay. Now, something I didn't touch on earlier was with all these grips, you can see as you grab them, you can also dynamically change them. And if it's not compliant, it will actually start throwing some big warning symbols at you as you do it. And all the objects, all dynamic, so as you move them around, as they're interacting with other objects, everything all changes like that. So pretty cool, pretty exciting. When I was doing this, I couldn't believe how quick and easy it was. So okay, so we're happy with our roundabout. We now go through and actually build our corridor. So come back. Okay. So come back into our edit settings. Now, for those users who have done any modelling of roundabouts, this is actually quite an amazing process. But come back up to where is it? corridor in here. So once I enable this, it will actually go through and create our alignments and the profiles, update them, and also create the corridors and things like that. So let's go apply. Should have gone okay. And down the bottom left-hand corner of my screen, you can now see the progress bar is flickering down there. It's actually going through and actually building it. You can see little magenta circles now being placed on the roundabout. It's actually constructing and creating all the alignments, and now it's actually generating a corridor as well. Okay. So close that. There's my model corridor. Come into my object viewer. Graphics catch up. And if you look closely, you can see all the different regions with all the corridors, all done straight away. You know, it's just almost as magical as the intersection tool in Civil 3D. It's quite amazing to watch it work. Okay, now that we've got our roundabout, we can now actually create a surface from that and then actually drive a vehicle on it. So let's quickly do that. So create our surface, so create a corridor, come into corridor surfaces, create new surface, final ground, add the links, come to the boundary and setting my corridor extents. So what it's doing now, it's actually creating a surface for my vehicle to drive on. Now, not a perfect surface because I haven't actually gone through and actually set up all my links and everything in it, so it will be a little bit lumpy. But just for the purpose of the demonstration, it just gives you a bit of a feel for how it works. Okay, now that I've done my surface, I now need to tell the program that my junction is using that surface. So come back up to here, final ground, okay to that. So told the object, but we also need to tell the drawing. Come back into the surfaces, final ground, then go okay. So now that's ready to go to actually do our vehicle turning. So come back to our auto drive, use our 19-meter semi that we used before. So, okay, proceed. And now that because I've told the roundabout that that's my particular design vehicle and the surfaces and everything like that, the program automatically knows now the roundabout, the geometrics of it, which way I'm turning, and everything like that. So if I wanted to do a couple of quick vehicle turning movements, place my vehicle, and if I want to do a right-hand turn at the roundabout, all I have to do is just place it where I want it, and the program automatically knows where the vehicle goes and also the correct vehicle path to place it. Saves you having to manually draw the vehicle track in. It just knows automatically straight away that's where it is. All right, so last item, we then do an animation. So last time I did this, I had some issues with my computer, so that's why I saved this for last. So, okay, so I've got no roundabout, so I'll just quickly close that. And set my existing surface to no display. Let's try that again. Okay, for some reason I can't see my roundabout, not sure why I can't see it, but as you can see, as it's going through the as it's going through the roundabout, in inverted commas, you can see the trailer is actually moving as it's going. But again, you can animate it, send an AVI, record what you'd like. So that's all I was really going to demonstrate today. There are other vehicles that you can do with AutoTrack, so we've only really just sort of touched on some of the basics today. So we'll just quickly go back to our PowerPoint slide. This slide here. Okay, so just quick rundown. We do have some for our Civil 3D users. If you're interested in a bit more in cul-de-sacs and corridors, my colleague is actually presenting a couple on those. Note the dates. Cul-de-sacs one is a little bit close to Christmas, but if you aren't able to tune in for the webinar, you can actually go to our website, and there's a webinar archive there that you can actually access it. So the one that I've presented today will be uploaded in a couple of days after I finish presenting. Those who are interested in Navisworks, there's a presentation on timelining, and especially relating to using MS project files to actually set your 4D timelining in relation to a project. There's also another one on people simulation in regards to BIM. That's a very interesting one as well. And then finally, something a little bit close to heart, a bit of recap. I've done a previous presentation on that. One of our guys from buildings or AEC, architecture realm, is actually going to be doing one on that. So I think that'll be very interesting, that one. But any future ones, you can just register online at that web address. So atkTechnologies.com.au/events. That'll tell you a list of all the webinars that are coming up and any training courses that we have as well. Okay, just a quick one, just to let you know what's happening over Christmas. We've got to have a holiday sometime, so we're actually closing from the 20th of December through to the 6th of January. So all our customers out there who rely on support and aren't fortunate enough to have a Christmas break this year and they need some support, then it's really important that you can still log all the support calls via our support portal, or you can actually then, and then what happens is we'll actually deal with those as we can. And once you're on our portal, there are also some knowledge-based documents and things like that. And depending on urgency and stuff like that, we'll just work our way through them. And there's also some other further links there on the Autodesk website if you're unable to contact us. So. Okay, questions and answers. So that's favourite part. So if you have any questions, feel free to shoot. So let's have a look. Okay, so one question is there, did you say that the roundabout tool builds a corridor? Yes, in Civil 3D, it will build actual corridor objects. I can go back, so we'll see what other questions I have there, and I'll jump back into Civil 3D to actually show you what the corridor looks about. Can the roundabout handle 5 roads coming and intersecting? I figured that as long as you have the space for the number of legs, it will actually allow for those. Let's have a look. One for architecture is Revit related. Unfortunately, at this time, there is actually no vehicle tracking is not available in Revit. I'd have to confirm with Autodesk what that availability is. I imagine that it's not if, but when that it will be available in Revit. So unfortunately, at the moment, it's still only available in AutoCAD and verticals. Right, so that's some of the questions that I've had so far. So what I'll do is I'll just go back to Civil 3D and back to the that. Okay, so back into my roundabout. Now if I click now to confirm that it's actually a corridor, all I have to do is select on the object that has all the links and everything in it and comes up as a corridor there, and then I can go through and actually modify the corridors properly. So go into properties, and in here has all the regions all set up with all the different assemblies. So I'll just widen that out a little bit more. So you can see it goes through and it models up each leg of the roundabout, the apron and the crown in the middle, and then from there it goes through and actually then labels up or sets all the regions for all the different roundabout legs and what area that it actually models for that in there. And also if I come across to my prospector, under alignments, it automatically has generated all of those as well. So I can go through, so there's my first street and my second street, which is my major alignments that cross, and then from here, these are all the items that have been generated by vehicle tracking. So pretty exciting, pretty cool, especially if you want to model up and quickly develop some options with roundabouts. Obviously, I've only done a single lane, but you can also do dual lane options as well. Okay, just double checking to make sure I have any more questions. If you're unsure how to ask a question, you can just go back to the panel on the right-hand side there, and there's an area that says questions, and then you can actually type in there. So ask it, let's have a look. Okay, another question. Can we create or customize a vehicle size, i.e. a disabled vehicle? Okay. All right, so back in the vehicle library, we can come across into here. So there's a whole, all the different libraries that you want to choose. So for example, if you do want to create a disabled vehicle, you can actually take a copy from an existing vehicle. So for example, right click on this one, then go, oh no, not new library. Trying to remember, I think it's this one here, the vehicle wizard. Go through. Have a vehicle. So you go through, say what kind of vehicle it is, and go next, and then you can go through and then actually start specifying all the different options and the dimensions as there. So let's cancel that one. As you go through the vehicles, let's have a look. You'll notice that, say for example, a B-double with different tractors and stuff like that. What you can do is, if you have a particular type of truck, say a Volvo or another brand, you can then actually just have those dimensions there and create another vehicle, and then actually drag and drop those particular trailers onto other vehicles, so you can then go through and actually build your custom vehicles at the same time. Okay. So last final question. Okay, question about the profiles earlier for the roundabout. Just close the vehicle library here. These profiles that I have here, go back to home, profile, existing, add. So at the moment, these ones here actually didn't have any geometry in them at all. So if I just go to the profile, next, put that there. Okay. So when I first, so basically it's just a normal normal horizontal alignment. I didn't actually have any vertical in it, and what I told it to do was actually just use the existing ground as the design. I do when the roundabout was modelled, they do have assemblies in here that make up all the different components of the roundabout as well, and they're all placed there in the drawing. So just to summarise, so when you go to model a roundabout, obviously you need to place your centre lines first, then apply your vertical, so do your horizontal geometry, then your vertical geometry. Then once you've done that, you can then actually go through, run the tool, and then the program will actually then go through and pick up that information from those profiles and amend those appropriately. Okay, well that's all we've got today, so I went a little bit over, but everyone, thank you for attending today. And if you have any more questions or anything like that, feel free to contact us. Here's my details here. So 1-800 number for those in Australia. Sorry I don't have the New Zealand number up there, but if you go to our website there and contact us, we will actually have the contact details for each region. So yep. So thank you for joining us today, and I hope you enjoyed the presentation. Thank you.